Good morning, everyone. I'm Ray Zhu from Carnegie Mellon University. Today, I'm going to present our work on rethinking reprojection, closing the loop for post-aware shape reconstruction from a single image. Shape from a single image has long been a problem of interest in low-level computer vision. To solve this, people often utilize this golden standard called geometric hues to minimize reprojection error of key points or silhouettes. And in recent years, with deep learning, people are looking for data-driven solutions to this problem. A pioneer of these methods is called Teal embedded network, and this method consists of two stages. In the first stage, they train an autoencoder to learn a latent space of subcategory object styles. The decoder here serves as the shape generator, mapping from a latent style vector to a shape in 3D. In the second step, they further train a style regressor from image to the latent space with synthetic images. And in testing, you feed in a natural image, and hopefully the network outputs a full 3D shape. The problem of this method is it is learned purely based on image appearance, and the appearance of the training domain, which is rendered images, can be different from the test domain, natural images. And we refer to this issue as feature gap. So this limits the generalization ability of this approach on natural images. So why don't we just directly learn on natural images with 3D annotations? Well, these annotations are expensive, so there are just too few of them. For example, there are less than 300 cars in learning settings, in clean settings labeled with shape and pose in the Pascal 3D dataset. But on the other hand, we have 30 times more 2D annotations, that is, the instance segmentation masks, for example, from the MS COCO dataset. And they are easy to annotate from crowdsourcing. So it could be just an invaluable source for us to train these networks. So can we take advantage of these cheaper 2D annotations as weak constraint in our task for end-to-end training instead of using only 3D shape ground truths? So imagine we could somehow reproject the reconstructed shape back to the image with a camera. And the reprojected silhouette should ideally match the ground truth. So we are able to use the reprojection loss as a weak constraint for both the style and the camera pose. This is a TL network. We make two major changes to this pipeline. First, we add a vanilla pose regressor, and we train the style and pose regressors with synthetic data. In the second step, we reproject the estimated shape back to the image plane with the estimated pose, and we fine-tune our two regressors on natural images with the 2D reprojection loss. And we call our method post-aware shape reconstruction from a single image. For the results, we observe better results on natural image domain, both in the object style compared to the TL network and the camera pose against methods like render for CNN, which estimates rigid body pose of an object. So the takeaway of our method is 2D geometric cues like reprojection loss can work as weak constraints on 3D shape or camera pose. So this is what comes next to this work. For videos, we could exploit temporal consistency by using the pixels themselves as the weak constraint. This is going to appear on WACV 2018, so stay tuned. Thanks.